So in the last video, we talked about applications of exponential functions. We talked about different bank accounts and how you get interest in those banks, right? For putting your money in, they give you a certain amount of interest. And that's just so that they can lend out your money and they can use it, they can invest it, they could give people loans, and they're using your money to do that. So the question is, okay, so we talked about the fact that they do this, but how does it actually work? Okay, so when I do these examples, I'm going to use really large interest rates. I want you to think about banks. When you go into a bank and you put your money in there, the interest rate that you get, depending upon the account, could range from 0.025% to maybe 2 or 3%. It's not very high, okay? And it depends very much on the economy. The interest rates that I'm going to be using are going to be like 10%. And that's just so that the numbers are changing enough so that you could see the differences. So let's say that you go into a bank with $1,000 and your account gives 10% interest each year. So we're talking about annual interest. Each year is annual. Okay, I'm going to write this down. So $1,000 would be your original amount. Let's see how much you would have after a year, okay? And again, keep in mind 10% would be huge. And keep in mind that when we do this, we're assuming that there aren't any, you might be making deposits or withdrawals, but the way the bank does it is they look at how much you have on that very last day. So let's say that you go in on January 1st, 2021. So January 1st, 2021, you have $1,000 in your account. After a single year, you're going to get interest, and you'll get your interest on January 1st, 2022. Okay? And the way that the bank does it is they look at how much is in the account December 31st, 2021. So the previous day. That's what they look at. So whether you make deposits or withdrawals at any other time, it's irrelevant. We're going to say that $1,000, we're going to assume that if you make any deposits or withdrawals, it balances out. But essentially, we're saying you haven't made any deposits or withdrawals. A deposit is when you put money in. A withdrawals is when you take money out. So we're going to assume that you don't touch this account. So after 1 year, we want to know how much you have. So in other words, how much is going to be in the account after you get your interest on January 1st, 2022? Okay, well now you have $1,000 plus an extra 10%. So how do we find 10% of $1,000? We take 1,000 times 0.10. Okay, so the 10%, that's the 0.10. We're converting it to a decimal so that we can actually do this multiplication and these calculations. Okay, so for our purposes, we can plug this into our calculator, but just so that we see how we might be able to calculate this after 10 years or 20 years, what we're going to do is we're actually going to factor out this 1,000. We're going to bring it out to the front, and we're going to say that this is the same thing as $1,000 times 1 plus 0.10. Okay? So let's just make sure that a couple of things are clear here. The 0.10 times 1,000, this is the 10% of 1,000, which is your interest. Okay? Over here, when we do this, this 1 represents 100% of what you have. That's the 1,000, the original $1,000. So you get your original amount, and then plus an extra 10%. So this is 100%, because you still get what you have, plus the 10%. So in other words, when you go into the bank and you calculate what you have after a year, you're taking 110%, okay? And what does this equal? This means that at the end of the first year, you have $1,100. Okay. This makes sense. 10% of 1,000 is 100. You get an extra $100 in interest. So at the end of the year, you have $1,100. Okay. After the second year, we want to know what you have. Okay, so now at the end of January 1st, 2022, you have $1,100. Now we want to know what you have January 1st, 2023. Now remember what we said. We said that you're essentially not making deposits or withdrawals, or they balance out. So on December 31st, 2022, in other words, the day before this, when the bank looks at your money, you have $1,100. So let's figure out how much you have. So this is saying, okay, well, you have $1,100. And now the bank is going to take 10% of that, and that's your interest. So in order to get 10% of 1,100, we know that we take 0.10 times 1,100. Okay. Okay. But again, we said, well, for the purposes of this calculation, what we're going to do is we're going to factor out 1,100. So it factors out in the same way. We take 1,100 and bring it to the front, and what do we have? 1,100 times 1 plus 0.10. Okay, well, why is this significant? Because we know what 1,100 is. 1,100 is this right here. So 1,100 is 1,000 times 1 plus 1.10. So we're going to substitute. We're going to say that this is 1,000 times 1 plus 0.10. That's what 1,100 is. And then we multiply by 1 plus 0.10 again. Okay, so we replace the 1,100 with this. And then we multiply by 1 plus 0.10 because that's what we have here. And that's what this is equivalent to. We just did a lot of substitution here. Okay, so we took the 1,100 plus 0.10 times 1,100, factored out the 1,100, and then replaced 1,100 with what we did up here. Now, why did we do this? Because now we have 1 plus 0.10 twice. And there's a short way of writing that. The short way of writing that is 1,000 times 1 plus 0.10 squared. I'm going to just rewrite that too, because I don't think it's super clear that it's a 2. Okay. Now, if you don't see now why that's significant, that's okay. You'll see it as we keep going. Okay. And what we get here is $1,210. So notice your money is just sitting in the account, and now instead of 1,000, you have 1,210 without doing anything. Okay, let's keep going. Let's see what you have after 3 years. And hopefully you'll start to see a pattern. So after 3 years, meaning we want to know how much you have on January 1st, 2024 now. Okay, well, we know that in the previous year, you had 1,210. So December 31st, 2023, that's one day before this, you had $1,210. And you're getting 10% interest. So you're multiplying that 1,210 times 0.10. And we're going to go through the same process. We're going to factor out the 1,210. But we know what 1,210 is. 1,210 is this. 1,210 is this. So 1,000 times 1 plus 0.10 times 1 plus 0.10. That's 1,210. But then we still need to multiply by one more 1 plus 0.10, right? Because it's 1,210. Sorry, I lost my mouse. It's 1,210 times 1 plus 0.10. Right here, 1,210 times 1 plus 0.10. So we need to multiply by 1 plus 0.10 one more time. And you can see that there's a short way of writing that, right? So this is 1,000. And how many times do we see 1 plus 0.10? We see it 3 times. So after 3 years, we're multiplying by this 3 times. And we can use a power to represent that. So here we have our exponents. And we also see a pattern. And this is equal to $1,331. Okay, so now we have this pattern that we're developing. Okay, after 1 year, we have 1 plus 0.10 once. After 2 years, we have 1 plus 0.10 twice. And after 3 years, we have 1 plus 0.10 3 times. So now what we can do is we can figure out, okay, how much do we have after 10 years? Because we have this pattern now. So after 10 years, we don't even have to know what year this is, but it would be 2031, right? But it doesn't really matter. Now, the thing is that in each of these, we started off by knowing what we had the year before, right? But after 10 years, we don't know how much we had after year 9. So we have to take that into consideration. Now, here's the thing. Because we factored out and we figured out that we can just take 1,000 and we can multiply it by 1 plus 0.10 3 times for the third year, 2 times for the second, and 1 time for the third, We don't need to know how much we had in the 9th year. All we have to do, so after 1 year is 2022, after 2 years it was 2023, so after 10 years, we're talking about January 1st, and it's actually going to be 2032, right? So don't worry about the date so much if that's confusing to you, okay? Sorry, 2031. See, even I get confused. Okay. So here, this is going to be 1,000, and we're talking about 10 years. So we're going to take this and multiply it by 1 plus 0.10 to the 10th. And if you put that into a calculator, you're going to get $2,593.74. Okay. After 20 years, we can do the same thing. So we don't know how much we have in the bank after 19 years. But we can do exactly the same thing that we did here. So 20 years, we're talking about January 1st, 2041. And same thing, we know that we take the original and then we just multiply by 1 plus 0.10 20 times. And again, if we plug that in, we get $6,727.50. Okay, so a couple of things to remember. Okay, when you put this into your calculator, calculate the 1 plus 0.10 first, raise that to the 20th power, and then multiply by 1,000. Okay, that's important because order of operations. Let's go to the calculator here. And I just want you to see how to plug it in. So we would type in, if you're good at using parentheses, then you can essentially do this and you're not going to have a problem. If you're not, you're doing what's in the parentheses first. So we're doing 1 plus 0.10. That gives you the 1.1. Then you're raising that. So on this calculator, the raising to a power is x to the y. It's this button here. Some of you may have little carets, which are like upside down V's. So it looks like this on your calculator. Some of you may have that. And we raise it to the 20th. We do that first, and then we multiply by 1,000. So the multiplication comes last. Okay, and you can see we get 6,727, and we round up, okay, because 0.49 rounds up to 0.50. Notice we round to dollars and cents. That's because we are dealing with money. So I'm going to put that in here because a lot of people forget that. So round to the nearest hundredth. because we are working with dollars and cents. Okay, so let's generalize this. Here's what this means. We have a formula for determining what we need. We can figure out how much we have. That's our P, by taking the original amount and multiplying by 1, that's our 100% of what we have, plus the interest rate as a decimal, and raising that to the T power, which has to do with number of years. Okay, so let's just define each part of this formula. So P0 is equal to your original investment. So in the case of the problem that we just did, it would be $1,000. When you go into a bank, they refer to this original investment as principal amount. Okay, so our R in this formula is what we say the APR. APR stands for annual percent rate or annual interest rate and very important, it's as a decimal. And I'm going to box this because it's the most common mistake that students make is they plug it in as a percentage, and that makes your numbers insanely large. And then the last thing is the time. And this is in years. Okay, so let's change this scenario just a little bit. In the scenario that I gave you, you would put in $1,000 on January 1st, and then the following January, the bank would look at how much you had at the very end of the year on December 31st, and they would give you 10% interest. Let's change it so that instead of the bank giving you 10% after a whole year passes, they're going to give you 5% after 6 months, and then another 5% after the remaining 6 months. Okay, so they're taking the 10% and they're splitting it up into 2, and instead of giving you interest once per year, they're going to give you interest twice per year. So the same 10%, but they're going to divide it up into 2 times. So suppose the bank instead gives you 5% after 6 months and the remaining 5% after the remaining 6 months. Okay, so in other words, if we rephrase this, the way that we would describe this is you go into a bank to invest $1,000 with an APR of 10%, and we use the words compounded semi-annually. So the semi-annually means 2 times per year or twice per year. Okay, and the compounded is the word that we use for collect interest. The number of times you compound is the same thing as the number of times you collect interest. So if you compound 10 times per year, what they're saying is that they take the APR, they divide it in 10, and they give you interest 10 times throughout the year. At the end of the year, you still get the same 10%, okay? But you're getting that 10% over a lot more intervals, okay? So let's see how this affects how much you get at the end of the year. So we're going to, again, figure out how much you get each time that you collect interest. So instead of looking at how much you have after a year this time, we're going to look at how much you have after 6 months first. Okay, and we're going to jump ahead and sort of factor from the very beginning. Okay, so after 6 months, we're going to say that you have $1,000. And we know that to figure out how much you have, you're going to take that and multiply it by 1 plus 0.05. Okay, very similar to what we did here. It's just that we already factored out the 1,000. So we took the 1,000 and we multiplied it by 1 plus 0.10, and that gave us the 10% of interest, right? So here we're doing 1,000 times 1 plus 0.05. And what we get is 1,050. Okay, the 0.05 came from taking the 10% and dividing by 2. Because over the course of the year, we're still getting 10%. But that means that after every 6 months, we're only getting 5. So we get 5% the first time, 5% the second time. That totals 10%. Okay, so that's how much we have after 6 months. Let's look at how much we have after 1 year. So after 1 year, we know that we have the 1,050. And then we take that and we multiply by 1 plus 0.05 again. Okay, because in the account on December 31st, we got the $50 of interest. So we have 1,050 in the account. And then we're taking the 1,050 plus 5% of the 1,050. And we know that 1,050 is just 1,000 times 1 plus 0.05. So we're going to do a replacement here, a substitution. We're going to take the 1,050 and we're going to replace it by 1,000 times 1 plus 0.05. But we also know that we still need to multiply by another 1 plus 0.05. We have to multiply by this one. And we also know that what that means is we're doing 1,000 times 1 plus 0.05 twice. So notice at the end of the year, we're no longer just having this to the first power. Now it's to the second power. Okay, whereas previously it was just to the first. It was 1 plus 0.1 to the first. Now, at the end of the year, what that means is that we have $1,102.50. Well, when we only collected the interest once per year, we had $1,100 at the end of the year. But now we have $1,100 and then plus an extra $250. Okay, so we have more after a year because we're collecting interest on that interest. We're collecting interest on the extra $50. Okay, whereas before we were collecting 10% on the 1,000, now we're collecting 5% on 1,000 and then another 5% on 1,050. Okay, so, and that's kind of a big thing here. So we have more after 1 year than if we compounded annually. Because we are collecting interest on interest. Okay, so once again, we have this formula. So we can construct a formula. And the formula that we have here is very similar, right? It's going to be similar to this one. The difference is that we have to take into account that when we collect interest, we're actually not collecting R each time. We're collecting R over the number of times that we're actually compounding annually. So here we collected 0.05 divided by 2 because we were collecting interest twice per year. But if we collected n times per year, then what we're going to do is we're going to divide r by n. So it's going to be 1 plus r over n. And then instead of just raising it to the n power, it's actually, instead of just raising it to the t power, we're actually raising it to the n times t power. Because after a year here, we've collected interest twice already. If we were collecting interest, let's say 3 times per year, then at the end of each year, we would collect it 3 times per year. So at the end of 2 years, for example, we will have collected it 6 times. At the end of 3 years, we will have collected interest 9 times. Okay, so that's what the NT is. So once again, let's just write what each thing in the formula is. So we have P0 is equal to the principal amount. This is the more common way to refer to the original investment, which is why in this case I'm putting it first. So that never changes. Your R is your APR, but as a decimal. Your N in this case is the number of times it's compounded. Okay, and this is really kind of separate because you don't need it for the formula, but it's needed to make sure that you have understanding. Think about what R over N is. So R is taking the interest rate and you're dividing it into the number of times that you collect interest. So this is going to be the amount of interest you get each time you compound. Okay, so up here, it was 0.05. So the interest is 10%, and each time you collect interest, you get 5%. And then the NT is the number of times that you collect interest over a period of T years. This is NT, which is not coming out. So let me just rewrite that. Okay, number of times you collect interest in T years. And one thing that I want to point out here is if your N were equal to 1, meaning you're compounding annually, then we could plug in 1 into this formula. And when you do that, you actually get the formula from above. Right? You get this here. So this formula is actually not all that relevant when we're solving problems. this formula is relevant in order to derive this one, in order to have come up with this one. So this is the big formula that we have. Okay. Okay, and just as an aside, some of you are not familiar with some of the wording, so I'm just going to put it down as like extra vocabulary. For compounding, so if you compound semi-annually, we know from the previous problem means twice per year. So your n is equal to 2. Quarterly means that your n is equal to 4. Monthly, there are 12 months in a year, so that means that your n is equal to 12. Weekly, there are 52 weeks per year, so n is equal to 52. Daily, n is equal to 365. And annually, n is equal to 1. Okay? So just basic vocabulary. Okay, we have one more situation. And in this situation, we're saying that you're going to compound an infinite number of times per year. We say that by saying you compound continuously. So let's take a look at what happens then. So if you compound continuously, then we're saying you're compounding an infinite number of times per year. Okay, but you can't plug in n equals infinity, right? It just doesn't work. You can't plug in infinity into a formula. So that means that we have to use a different formula. Okay, so let's figure out what that formula is. Well, in order to do that, what we're going to do is we're going to create a table, and we're going to take the part of this formula that just uses n. So we're going to ignore the p0. We're going to just set everything else equal to 1, okay? We're going to ignore the p0, ignore the r, and ignore the t. And if we set everything else equal to 1, then we can create a table where we use n and 1 plus 1 over n to the n. Let's start by plugging in 1. Okay, what we're doing here is we're saying what happens when n gets really, really, really large, closer and closer to infinity. Because we're plugging in really large numbers. We can't plug in infinity, but we could plug in numbers that get really large. So when we do that, we have 1 plus 1 over 1 to the first power. That just gives us 2, right? 1 over 1 is 1. We add that to 1, that's 2, and 2 to the first is just 2. Okay, well, if we plug in 1,000, so we're getting larger, we get 1 plus 1 over 1,000. That's equal to 2.716923932. Okay, let's plug in 10,000. Well, if we just replace the 1,000 here with 10,000, what we get is 2.718145927. Okay, well, let's plug in a billion. A billion is 9 zeros. Well, in this case, we get 2.718280469. Now we could keep going, and I'll tell you what we get if we keep going. We get 2.718281828, and it keeps going. This is an irrational number. We get closer and closer to this number, and this number is called E. Now here's why that happens. 1 over a very, very large number gets closer and closer to 0, okay? And because of that, this 1 plus 1 over n just keeps getting, it gets closer and closer to 1. So 1 raised to a really large power, well, it's just a little bit more than 1. It's never actually 1. 1 raised to a really large power is 1. But we always get a number that's a little bit larger than 1. So what's happening is these numbers are getting closer and closer together, right? Originally it was 2, then it was 2.7169. Now it's 2.71814. Now we get 2.71828. The distance between the numbers is getting smaller and smaller. So as n gets really, really large, we actually approach a number, and that number is E. It does have a name. It's called the Natural Exponential Function. That's what e to the x is. Okay. And we can use this to create this new formula. So this new formula is P is equal to P0 e to the RT. And we only use this if it says compounding continuously, because this tells us that n approaches infinity. So this is our second big formula here. Okay, and once again, let's just write what the different parts of the formula are. So your R, once again, is your APR as a decimal. Everything represents the same thing. Nothing changes. Your P sub 0 is your principal. And your T is your time in years. Now, there's one more thing I want to mention before we go through some examples. Two more things, actually. The first thing is when you go into a bank on brochures, they don't have APR. They actually have APY. And there's very little difference between APR and APY, especially when percentages are really low. So like 10%, it's a bigger difference. But when it's typically what a bank might offer, like 0.05%, APR and APY are essentially equivalent. Here's why. The APY is the annual percentage yield. And the annual percentage yield is the actual interest that you get at the end of the year. So the APR says 10%, but you're actually getting a little bit more than 10%, right? The 10% would be if you compounded annually. The 10% doesn't take into account the fact that you're collecting interest on interest. The APY does. So the APY is telling you, okay, well, you're not really getting 10%. You're really getting like 10.2%, okay, or 10.02%. So you're really getting a little bit more than 10%. So the APY takes that into account, and it's the actual interest that you get. So it's telling you, well, you're actually getting 10.02% at the end of the year, to be exact, 10.025%, okay? So let's just write that down so that you have it. The APY, and I want you to know it because I want you to understand what you're seeing on a brochure at a bank or online. It's the annual percentage yield, and it's the actual percent interest. Taking into account the number of times you compound. Okay. The next thing before we go through examples that I want you to think about is, why would a bank compound continuously? Okay, the reason why is, let's take a situation. Let's say, for example, that you deposit $100 in March. So you start off with $1,000, you deposit $100 in March, and then you withdraw it again in November. Well, if the bank compounds annually, then none of that really matters, because on December 31st, you still have $1,000, okay? So compounding annually doesn't really take into account your deposit and then your withdrawal. If the bank compounds, let's say semi-annually, so more often, then in June, you're getting interest on $1,100 instead of just $1,000, right? And then in December, you're getting interest on, whatever you got minus your 100. So it's still benefiting you, because in both cases, you're still getting interest on more than $1,000, okay? Okay, but let's switch it. Let's say that instead of depositing in March, you withdraw in March and you redeposit in November. Now, if you withdraw $100 in March and you redeposit in November, if it compounds annually, then it still doesn't affect how much interest you get. You're still going to get the $1,100 in January. But let's say it compounds more frequently. Let's say it compounds semi-annually. Now, in the other case where you deposited and then you withdrew, it didn't affect you. But now, since you're withdrawing in March, then in June, after 6 months, you're not getting interest on $1,000 anymore. You're getting interest on only $900. This is where it helps the bank. Because when you withdraw money, compounding continuously helps the bank. Whereas when you deposit money, it helps you. And the way that the bank looks at it is you're going to feel like it's a positive. You're going to feel like it did something good for you, okay? But, sorry, I was just fixing this. This is a U. For some reason, it just didn't come out so well. Okay. You're going to feel like it did something good for you, but it actually balances out. Sometimes it'll benefit you, sometimes it'll benefit the bank. And in the end, it's really not going to make much difference than when they compound it annually. Okay. Okay, so let's just go through some examples. I'm going to do 4 examples, and after I tell you what each one is, I encourage you to just stop, try it on your own, and then start the video again. Okay. Okay, so let's take the first one. So suppose you invest $23,000 with an APR of 2%, compounded three times per year. So the question is, how much do you have after 7 years? So solving these problems is a 2-step process, okay? The first thing that you're going to ask yourself is, are you compounding continuously? Now, you're not compounding continuously because it says that you're compounding 3 times per year. So that means that you're not going to use this equation here because this equation is only for compounding continuously. Instead, you're going to be using this one. And remember, you don't have to worry about compounding annually because this one takes care of that. So it's not compounded continuously. Which means we use P is equal to P0 times 1 plus R over N to the NT. Okay, so this is going to tell you which equation. The second part to this problem is then just identifying each of the pieces inside of here. So P0 is your original amount, and it tells you that that's 23,000. Your R is your APR divided by 100, because it's as a decimal. So it's 0.02. Your N is 3, and your T is 7. Okay? And you would just plug this into your calculator. Okay, and to plug it into your calculator, you're going to do what's inside the parentheses first. Okay, so let me just write this, that your P is 23,000 times 1 plus 0.02 over 3 to the 3 times 7. Okay, this is a 3. Sorry about that. I don't know why that's not coming out. Let me try it again. Okay, that's a 3. Okay, so you're going to do the 0.02 divided by 3 first. Then you're going to add 1. This is order of operations, right? You add 1. Then you're going to raise that to the 21st power because that's what 3 times 7 is. So on this calculator, raising to a power is this x to the y. 3 times 7 is 21. And then you multiply by 23,000. And you get $26,441. Sorry, $44.01. Okay, you're rounding to the nearest hundredth again because you're dealing with dollars and cents. Okay, let's take another example. So suppose you invest $8,000. With an APR of 0.5%. Okay. This time compounded continuously. And we want to know how much do you have after 10 years? Okay, so again, you're going to ask yourself, is it compounded continuously? So in this one, we see the words compounded continuously. So yes, it is. So it's compounded continuously. Which means we use the second formula with E. Okay, and then we identify each of the different things. So here our R is 0.5 over 100, which is equal to 0.005. You're going to know that you forgot to plug in a decimal because your answer is going to be much larger than it should be. Okay. Your T in this case is 10. Your P sub 0 is 8,000. So if we plug this in, we get P is equal to 8,000 times E to the 0.005 times 10. And if we do that, you're going to do, so E is on your calculators. If you don't see it, sometimes it's over the LN button. Like there's an ln, it might be over the ln button. So you would do e to the power of, in parentheses, 0.005 times 10. I put 2 parentheses just because I accidentally put a second one. You take that and then you multiply by your 8,000 and you get $8,410.17. So $8,410.17. Okay, let's do another one. I'm going to put this in kind of shorthand just for time purposes. So when you get a problem on a test, it's going to read more like this. Okay. In this one, you invest $12,000. Your APR in this case is 0.25%. And we're compounding monthly. And we want to know how much after 16 years. So again, you're looking at, does it say compounded continuously? It doesn't. It says compounded monthly, which means that we're using this equation with n because we have a value for n. And then we're identifying what each thing is. It's all given to us in the problem. P0 is 12,000. R is equal to our 0.25 divided by 100, or 0.0025. Our N is 12, and our T is 16. So we get P is equal to 12,000 times 1 plus 0.0025 over 12 to the power of 12 times 16. Okay, and if you plug this into your calculator, you're going to get P is equal to $12,489.68. Okay, which again makes sense. It's such a small amount of interest that after 16 years, you're really not going to make that much money. Let's do one more. So in this case, you invest $25,000. Your APR is 3%, and it's compounded continuously. We want to know how much after 8 years. Okay, so we're asking ourselves again. I pause the video to try and do it on your own. So we're asking ourselves, how is it compounded continuously, or is it compounded something else? It's compounded continuously. That means that we're using P is equal to P0 e to the RT. Then we're identifying our P0 is 25,000. That's the original investment. Our R is 3 over 100. Notice if you forget to divide by 100, that's the equivalent of saying that it's 300%. Your final answer will be huge here. So you're going to know that you made a mistake. And your T is equal to 8. So if we plug that in, we get 25,000 times E to the 0.03 times 8. And if we plug that into our calculators, we get $31,781.28. Okay, and that's it. And the only other thing that I'll note before I let you go is that it doesn't always have to be with money. We can do these problems with anything. If it's talking about population, you have your original population, you have the growth rate. So APR is the same thing as growth rate, okay? And your growth rate, again, would be your percentage increase divided by 100. And then compounded, same thing. It's either compounded continuously, monthly, annually. If it does not say, you can assume it's compounded continuously, okay? If it does not say, you can assume that it's compounded continuously. Okay, and that's it.